Okay, I got 97. That's this angle, okay? 97. (97, 51, 12). My azimuth for line BC is this. There's my azimuth. Azimuth of BC is right there. What do? It looks like the azimuth plus that 97, 51, 12 has to add up to 180. So I'll take this. It looks like my azimuth is 820848. So there's my azimuth of line. This is 820848. 820848. Azimuth of 820848. There's one of them. Okay, I'm going to put another axis over here. You can see how where I'm going, hopefully. There's my vertical line. Oops, don't do that. This is where you get in trouble right here. This one's pretty close. There's my line. And if that is right, what do I got there? I've got 75112 right here. 75112. How do I know that? This angle is 97, so that angle right there has to be 75112, and it's opposite, so that has to be the same. So it looks like, let's see, if I take and add those two numbers together, you can see this is a process where you got to just think, talk to yourself, move methodically from point to point. It looks like, if I got this right, it looks like that little guy right there, plus 80, plus 7, has to add up to 90. So I'm going to take 80, 58, 42, 80, 58, 42. I'm going to add to it 75112. And I'm going to find out how much of that 90 degrees is eaten up by these two numbers. That's 54. 9, 187. So this angle right here, from there to there, is 88, 49, 54. That little guy has to make it 90, so what do I add? I add 110.06. Looks like if I add 110.06, that's this little guy. So those three angles add up to 90. Here's my azimuth right here. What is that? It's 180 plus that 110.06. So it looks like the azimuth of CD is 181.10.06. There, I got it. You can see if you got that screwed up, it's going to mess up your calculations real quick. So let me draw another line here. That's 110.06. Okay, and what do I need? Looks like I need this. I'm going to draw it in red. There's my azimuth. So what do I do to get that now? Now, you guys that want a formula for everything you do in life, you're in trouble. Because this is not a formula. This is a little bit of thinking, heavy thinking. Okay, if I get that, if I got this angle, and I subtract it from 360, I'm home free. So I'm going to do it. 116, 19, 12. From that, I'm going to subtract 110, 06. So from here to here is 115.09.06. If I subtract that from 360, I believe I have my azimuth. So 360. $244.50.54. Okay, that's it. 44.50.54. So that's the azimuth of line DE. 244.50.54. There's that one. And now I'm going to do my next to last. Throw this guy right here. Throw this guy right here. And if that's 244, that means this is what? It's 270 all the way around. 25.09.06. 25.09.06. Okay, little math. What do I need? Here's my azimuth. I need that angle right there. How am I going to get it? Well, I got myself a mess going on here, don't I? Well, it looks like if I get this little angle here and add it to 270, I've got what I need. Okay, how am I going to get that little angle there? It looks like this plus this plus this has to add up to 180. So let's do it. I got 92.04.42, 92.04.42 plus 25.09.06. And I need to add up to 180. So 179.59.60 from 117.13.48. $62. That little guy right there is 62.46.12. If I add 270 to it, looks like I got 332.46.12. So that's the azimuth of this guy. $332.46.12. Okay, I've done all this work. I come up with all my angles. Why would I not want to check and make sure what I've done has some merit? So, what am I going to do? I just figured this guy right here to be 62, 46, 12. If that's the case, this one has to add up to 90 degrees. 27, 13, 48. And that's that. What do I know about those three numbers? 51, 101, and 27. They're all in a straight line. So if I take 51, 22, 00, 101, 24, 12, and 27, 13, 48. If I add those three numbers together and they do not add up to 180, guess what I get to do? I get to go back and try to figure out where I screwed up. You don't want to do that. You want to do it right the first time. 12 is 60. 6, 9, 5, 9, 7, 1. 179, 59, 60. 60 gives me one extra. 60 gives me one extra. Bingo. I'm exactly where I wanted to be. That means I closed. That means that everything I did looks to be right. Okay. Now the only thing I need to do to get myself in a position to determine latitudes and departures is to take the sine and cosine. And you have most of you have the TI. You can put degrees, minutes, seconds in it. I prefer to take and reduce them into decimals. If you have a construction calculator, it does it automatically for you. If you don't, you have to do a little math. So I'm going to do that right now real quick, and that'll end today. 22 divided by 60. 3 and a bunch of 6s. That's 51.3 and a bunch of 6s. Okay, clear. 48 divided by 60. 8.8. Six is 0.1. .9, 50.9. Okay, all I've done now is taken and changed degrees, minutes, seconds to decimal. And let me show you how you do this if you don't have the calculator that will allow you to put numbers in and do it, okay? So let's take that 181.10.06. Okay, 181 1006. If you got the construction mate, you put 181.10.06, push convert degrees, minutes, seconds to decimal degree, and it'll do it for you. If not, you got to take this guy, divide it by 60. So this now becomes 181 degrees, 10.1 minutes. Then you have to take the minutes and divide it by 60. And when you take 10.1 and divide it by 60, 10.1 divided by 60, you get 0.168 and a bunch of threes. 0.168 and a bunch of threes. That little line over the top of the 3 means it's repetitive. So that's how I got that over there. 181.168333333. Okay? So now I'm at the point where I can move on and I can determine latitudes and departures. And then once I get latitudes and departures, I can add them up and hopefully they add up to 0. If they add up to 0, it means my walk brought me back to point A. Over, across, over, down, down, down. I should end up exactly where I started. And the only way that can happen is if the sum of the x's and the y's add up to 0. Okay, that'll take care of this unit. And we've got one more in traverses, and then we're done with that.